Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 16 of our chapter, that is unit 7 P block elements, we are going to discuss about chemical properties, right, of group 17 elements. Now when we talk about in chemical properties, first we'll be discussing about oxidation state, what we say, right? So always remember that is in group 17 elements, all elements have -1 oxidation state, right? -1 oxidation state, all elements of group 17 element. But some cases when we say fluorine will always have -1 oxidation state. Clear? Now when we talk about fluorine will have always -1 oxidation state, the meaning is what? Because fluorine is the most electronegative element in the whole periodic table, according to Pauling scale. Okay. Now when we talk about chlorine, bromine and iodine, right, they will have oxidation state of -1 also and of +1, +3, +5 and +7. Now the reason for this, what we say, the positive oxidation state that we are going to discuss. Now this explanation of the topic in your textbook, they have explained, that is on page number 199 regarding the oxidation state. So they have shown one nice configuration, you can see, that is for halogen atoms, right, in ground state. What is the word? Ground state. Clear? Halogen atom in ground state, the configuration is NH2, NP5 and Nd if it is required, right? But first we'll discuss about this only. NH2, NP5 is the general configuration. So when I write like this in the orbital, you will see like this configuration, it means electrons are arranged in this manner, right? So in ground state, what is the word I am talking about? In ground state, what will happen? You will see that either there will be a loss of electron, or there will be a gain of electron, right? Means either it can lose this electron. If loss of electron is there, +1 oxidation state, will be there. If gain of electron means if it gain one electron means what? If loss of electron, if it is there, loss of electron means you will see there will be only this, like this, what will be there? Electrons in the orbit. But when we talk about gain of electron, this is loss of electron, right? When we talk about gain of electron, what you will see? You will see the configuration like this, what we say. Understood? So loss of electron, +1 oxidation state, gain of electron, -1 oxidation state is seen, right? Now this I am talking out in which state? I am talking out in ground state, what we say. Then now in the first excited state, what is given? Which one? The first excited state I am talking about. So first excited state. Now first excited state, what you will see? You will see the electron in the ns orbital will like this be only, and when we talk about this electron here, from here what we will see, one electron will go to Nd orbitals. Which orbital? Nd. Now we know in D there are 5 orbitals, what we say, 5. Okay, so in this case from here one electron will shift here. So in this case if you see there are 3 unpaired electrons. How many unpaired electrons are there? 3 unpaired electrons are there. What is the word? Here 1, 2 and 3. 3 unpaired electrons. Therefore oxidation state, by losing this electron, oxidation state will be equal to +3. Even they lose electron. What is the word? Loss of electron. These 3 electron it will lose, and the oxidation state will be what you call it as +3. Now this same thing, this was first excited state. Now suppose in second excited state, when we say here, second excited state, I will just change here for second. Clear? Second excited state, what you will see, this from here also electron will be shifted to this position like this. So here, like this, now if you see, there are total, how many electrons are there? 5 unpaired electrons. How many total? 5 unpaired electrons will be there, right? So 5 unpaired electrons means oxidation state by loss of electron will be plus 5. Understood? Then next is third, what we call it as excited state. Which one? Third excited state. Third excited state, what you will see, this electron will move from here to this position, what we say. So like this I will write, and I will remove this one electron. So total, if you count here, 1, 2, 3, 4, 5, 6, 7. So oxidation state due to 7 unpaired electrons will be plus 7. Okay. So this is the way how it shows this plus 1, plus 3, plus 5 and plus 7 oxidation state. This one is in ground state. The remaining, what we say, are in excited state. Understood? Now, what I said here, fluorine will never leave its electronegative because it's a highly electronegative element. So fluorine will always have -1 oxidation state. Chlorine, bromine, iodine can have negative as well as positive oxidation state. Positive will be by loss of electron and negative by gain of electron. Understood? So this was all about oxidation states of what we call it as group 17 elements. Now the next part. Now we are going to discuss about oxidizing power of different elements. What we say here, oxidizing power of different halogen. Oxidizing power of different halogen. Okay. Now when we talk about this oxidizing power of different halogen, one thing what you have to remember is, since halogen has a strong tendency to accept electron, they are all strongly oxidizing agent. Halogen have strong tendency to accept an electron. Okay. So here all halogens are all halogens have strong tendency to accept electron. They are what we call it as strong oxidizing. Clear? They are what? Strong oxidizing. Understood this part? Strongly oxidizing, you can write grammatic. Okay. Now when we talk about the next part, next part, when we say the upper halogen has the greater oxidizing power than the lower halogen. Now what is the meaning of that? Upper halogen have higher or stronger, what we call, oxidizing power than lower halogen. Clear? Now when we talk about lower halogen, means what? Group 17 elements, when we write group 17 elements, clear? Fluorine, chlorine, bromine and iodine. Acetate and all we will not discuss now. So upper means this one. So upper halogens have what we call it as higher oxidizing power. Higher, or you can also use the word greater. What is the word? Greater oxidizing power, upper halogen. And lower than lower halogen, what is given here. The upper halogen can oxidize halide ion of the lower halogen as follows. What is the meaning of that? See, in your textbook these all things are given, you can underline this. Upper halogen, what is given in your textbook, you can see, can oxidize halide ion of lower halogen. Can oxidize halide ion of lower halogen. Clear? Lower halogen means this all what we are talking about. Right? What is the line given in your textbook? The upper halogen can oxidize halide ion of lower halogen. Now what is the meaning? There it is, they have explained here. That is what? F2, when I write F2 plus 2xi will give you what we call it as Fx, that is 2Fi, F minus plus X2. Now in this case X you can take chlorine, bromine and iodine like this, what is given. Now What is the meaning of that? Means if I take here F2 plus what we say 2Cl minus, what you will get? You will get 2F minus plus Cl2, right? So what is the meaning of here? See, here it is minus 1, what we say, right? Oxidation power minus 1 here, and here for X2 it is 0. So minus 1 to 0 means increase in oxidation number, means it is oxidized, right? So upper halogen will oxidize the lower halogens by this, you can see, because they are more electronegative. They have more tendency to accept an electron. Understood? Here it is 0 and here for fluorine it is minus 1. So from minus 1 to 0 means oxidized, what we say. Understood? So this one is oxidized, so you can say it is as a reducing, and this one is as an oxidizing agent. Understood this part, what I said? Okay. Okay, next. Now this next point what I am talking about, that we will discuss. That is, there is a standard electrode potential is in the order. Now this you must have studied in electrochemistry. What is the word? Standard electrode potential is of the order. When we write the order, means the higher one, which is the more oxidative, what we call standard electrode potential, will be first. That is what? F2 greater than Cl2 greater than Br2 greater than I2, right? So this one will have higher oxidation, standard electrode potential, what we say. Understood? Now the next part. Okay. When we talk about this oxidizing power of different halogen, we have discussed about 3 points. Now the point number 4 we are going to discuss. Now what is point number 4? This you can write down in all your fair books and it will be easy for you, what we say. See, the oxidizing power can be compared by the reaction. What is the word? Oxidizing power can be compared by the reaction with water, right? Now what is the meaning of that? In your textbook when a reaction is given, you can see that is F2 oxidizes water to O2. F2 oxidizes water to O2. For that the reaction is 2F2 plus 2H2O gives you 4H plus. Now how it is so, you can come to know, plus 4F minus plus O2, what we say. Now in this case oxidation number of fluorine is 0. Clear? Oxygen here it is minus 2 and here it is 0. So F2 oxidize water to O2. So this water is oxidized to O2, what we say. Understood this part? And you can see itself get reduced. Who? F2. So this one will act as a which agent? Oxidizing agent. Who? I am talking about fluorine. It will oxidize water to what? O2. You can see here the reaction what is given. Understood this part? Now next one, chlorine and Br2 reacts with water to undergoes. Now this was of reaction of F2 with water. Now we are going to discuss about chlorine and what we call it as Br2. So chlorine and Br2, what chlorine and Br2 will do? So it will react with water. Br2 will react with water to give disproportionation reaction. Clear? Now disproportionation reaction means what? Same atom gets oxidized and reduced. So for that one reaction is given. Disproportionation reaction into hypohelic acid. Hypohelic acid. Now this you will study in oxo acids of group 17 elements. Okay, that topic is there. That when we'll discuss hypohelic acid and hypohellus acid. Clear? Now when we talk about hypohelic acid, you can see the reaction Cl2 plus H2O will give you what we call it as HCl plus HOCl. HOCl. Understood? Now in this case chlorine oxidation number elemental state it is 0. here it is -1, and in this case -2 for oxygen, +1 and +1 for chlorine, because oxygen is more electronegative than chlorine. So here if you see chlorine 0 to +1 means what? Oxidation. Clear? The same chlorine 0 to this -1, -1 here, this chlorine. So it is reduced. Clear? So same atom gets oxidized and reduced. That's why we call it as which reaction? Disproportionation reaction. Now this hypohelic, what we said, no, it is given in your textbook on page number 205 regarding this hypohelic acid. Clear? It is given on page number 205. Okay, there are certain oxo acids of what we call halogens are given. So you can see there hypochlorous acid. What is this name? Name of this acid is hypochlorous acid. Understood? So hypohelic acid means this part understood, I think, what is given. Okay. Then the next one is given for bromine also in your textbook. You can see. I will just rub this. You cannot see that now. So for bromine I will write now. Okay. So bromine reaction is like this. Br2 plus H2O gives you what? HBr plus what you call it as HOBr. Right? So hypohelic acid. What is the word? Hypohelic acid. And helic acid. Helic acid means this one. This one is helic acid. Understood? So it is given hypohelic and hypohelic. Sorry. Hypohelic. Right? Now this one you can see in this bromine 0, -1 and here +1. So 0 to -1 is reduction and 0 to +1 is oxidation, what we say. Understood? So this is an example of disproportionation reaction. Now in this case the name of what we call it as HOBr, what we have seen now is hypobromous acid. What is the word? Hypobromous acid. Understood? That way it is called hypohelic acid, what we say. Understood? So this was all about what we call it as acids, what I said. Okay. Hypohelic and hypohelic and all, now what we say, that based on the oxidation number, what we say. Now the next part we are going to discuss is regarding I2 does not react with water. That I am going to discuss. We have discussed about reaction of fluorine with water, reaction of chlorine and bromine. Chlorine and bromine is disproportionation reaction, right? Now this one we have discussed. Now iodine, regarding iodine I will write. See, now point number 5 what we are going to discuss, that is I2 does not react with water. The reason what we say, because I2 does not dissolve only. In fact, I2 does not dissolve in water. Clear? So this you have to remember. This is the reason why it does not react. Now the another point, that is point number 6 for this oxidizing power of different halogen you are talking about. Oxygen can oxidize. What is the word? Oxygen can oxidize. I2, that is iodine, what we say now, iodide iron to I2, iodine, that is, this is iodide iron to iodine. Oh, what I am talking about? Oxygen. So oxygen can oxidize iodide iron into iodine in medium is very important. In which medium? Acidic medium. Now this can be asked in your MCQ also. That oxygen can oxidize iodine to iodide to iodine in which medium? So it is acidic medium. You can remember this as an MCQ as follows. So the reaction we will see, that is 4I minus plus 4H plus O2. Now this you get from an acid, what we say, right? So 4HI also you can write if you want, plus O2 will change into what? 2I2 plus H2O. Understood this part? So this is what we say. Oxygen can change this. This is iodide, iron, into iodine. Understood? You can see who changed it? Oxygen. Okay, so this is the reaction which was given in your textbook related to this. You can go through it. Okay, so this was all about what we call it as oxidizing power of different halogens and chemical properties of group 17, in which we have discussed about oxidation states and all. Okay, so we will stop here. Next time, in our next video, we will be continuing with the anomalous behavior of fluorine. That is the first element of group 17, fluorine. Why do they behave differently, unusual behavior, that we will be discussing in our video 17, what we say. Understood? And remaining also the reactivity with what we call it as oxygen is there. In your textbook you can see on page number 200 and 201. Reactivity towards halogen is, hydrogen is there, oxygen is there, reactivity towards metal is there. This all comes in which property? Chemical properties. Then we will discuss about preparation of chlorine, dichlorine, what you say, Cl2. Okay, so here we will stop. Next video we will be discussing about the remaining chemical properties. This was chemical properties of group 17 element part 1. Clear? Part 1. So like this, another 2 parts will be there. 2 and 3 will also be there. So in the next video we will be discussing about that. Okay, thank you very much.